Right, sorry. So watch here. So really and truly, when we integrate, we are actually finding the area under the graph. So the way to find the area under the graph, right, without using integration is if we can convert this as shape, right? If this was a nice, let's just pretend it was a nice rectangle. And we could just use length by breadth and work it out. So length by breadth, right? And we can work it out. But look at this shape here. This shape is looking like a what? Looking like a trapezium, right? So if we split this up into equal trapezia, let's see how much we could probably get. We could get 1, 2, 3, 4, 5, 6. Let's say about 6. Let's say I were to split this up into 6 trapezia. One here. Next one here, 2, 3, 4, 5, 6. So if I were to split it into 1, 2, 3, 4, 5, oh sorry, 7. 7, right? 7 trapezia of equal widths and add them up. I will be able to find the area under the curve, right? But the problem with this is you would recognize that these are not perfect or perfect trapezia. So for example, you might get one here, might get one a little bit larger, right? So you might overestimate and underestimate at some point. So for example, I just saying like here, you might have a little piece remaining here. So this value that we are going to work out is an approximation, close to it, right? If you work out the actual integral and put in the limits, you wouldn't get its exact value. To be a little bit off, right? So what we are going to do is develop a formula that allows us to add up these trapezia to get this value. All right? How you find the area of trapezium again? Half the sum of the parallel sides by the height. Right? Parallel sides, height. Are you okay with that? So let's say all of these here h. Right? All of these widths here h. Let's see if we can make up a little formula, or I'll give you an idea of how the actual formula was derived, right? We're not going to derive the actual thing. So what is, yeah, head open, push it, head open. All right, so watch here. Right, so here is h, your area here is h by, right, half of the sum, so it's half h by, how we getting the height earlier? How we getting the height here? If you know the function, how do we get the height here? Anybody can guess? How do we get this height here? No. Anybody else? If we know the function and we know the x value, which is a in this case, substituted, right? So this here is f of a. Are you okay with that? How do we get this value here now? This next height. Very good. If here is a and this whole thing is h, then this is a plus h. So here will be f of a, and on top will be f of a plus h, and so on and so on and so on. Okay, so we're going to end up with f of a here plus f of a plus h. And then we do the same thing again for the second block, and then the third block, and the fourth block, and so on. Everybody okay with that? Yeah? So how do I get the perpendicular, the parallel heights? Plug in the x value into the function. That's okay? So your formula will be discontinued all the way down until the sixth one, right? So generally, here's what they came up with. Generally, we have generally we have the integral between b f of x with respect to this as right? 1/2 h by. Anybody have the formula sheet? I'm going to give you the one exactly in the formula sheet. Anybody have a formula sheet on that? Oh, wait, no, yeah, apply it out. You have to learn this. This will be in the formula sheet. I'm going to give you the exact one in the formula. Apply 1 to 1. Right. This is the one that in your formula sheet, so this is the one that we're going to practice to use, right? Right, Talia, watch here, please. In your formula sheet, right? In your formula sheet, there's a small error. What you will see is this, y to the n and a -1 up here. The -1 is really supposed to be a subscript here. All right? So I want to show you, let's see if this makes sense. You all see where this came from in the original formula? 1/2 h. This is your first perpendicular, first height, and yn is your last height. This one here. So y0 is your first height, yn is your last height. And then it have 2 by all the other heights. Anybody can tell me why there's a 2 here? Why do I have a 2 in front here as well? Think about it. Watch all the different keys here, right? These two do have a 2, but all the others have a 2 next to it. Why? Huh? Close. Look at this side. Look at this side. This is y0, because that's the first one, right? And this is y1. This is y2, y3, y4, y5, y6, y7. Right? This is y0 and y1, correct? What about this piece here? y1 and y2. So we're using y1 twice. We're using y1 for this one, and we're using y1 for this. Watch it again. Watch again. y2, y3. So we're using y2 for second trapezium, and we're using y2 for the third trapezium. Everybody okay with that? So all these sides we are using in the formula twice, except for the first and the last. Yeah? So that's why your formula looks like this. In your formula sheet earlier, there's a small mistake. I don't know which version you all have, but there's a small mistake where the -1 up here. Right? That's an error. The -1 should be down here. Darren, you can't come to class on time. Instead of going down, so I'm food basket. Right? So you're going food basket, buying a Fruitopia and a chocolate cake. How we get under it? Okay, so I'm going to show you how to use that formula to get it done, right? All right. Okay, so I was just trying to show you it here where it came from, right? We just adding up all the trapezia. Which one do you think would be more accurate here? If I have 200 trapezia or just 5? Which one do you think will give me a better approximation of the area? 200, right? So the smaller the trapezia, the more accurate the better. Right? And I was saying, right, so what will happen is, oh, I mean smaller width, I mean smaller width. Yeah, I mean smaller width, so I meant smaller width. All right, so we are going to use trapezium rule for an example, right? And that's all you have to know. You don't matter memorize this in your formula sheet. And that's why the understanding rule is, right? One line only, okay there? Right, write this down. Estimated area, estimated area, estimated area of the region bounded by the curve. Estimated area of the region bounded by the curve. Y is equal to 1 over 1 plus x squared. Estimated area of the region bounded by the curve. Y is equal to 1 over 1 plus x squared. And the lines 0, sorry, and the line x equal to 0 and x equal to 2, x equal to 0 and x equal to 2, using the trapezium rule, for 5 trapezium, for 5 equal 5 equal trapezium, right? So before we start, let's see if we can figure out what is H. You all figure out what E and B? E and B is what? 2 and 0. Right? H is B over A and N. So we know what is A and B. N is what? That'll be 5 equal, right? So it's 5. So it means that H is equal to, let's use, sorry, sir. Let's use 0.4, right? Okay with that? So now let's see if we can find every single thing in here. We need H, you need Y0, Yn, and so on, right? So we do another table. I want you to understand what you're doing, right? So you're starting from 0. So you're starting from 0 and you're splitting up 0 into 5 equal trapezium, right? So it will be 0.4, then 0.8, then 1.2, then 1.6, and then 2. You're seeing the x values? These are what the x values will look like. Trapezium 1, trapezium 2, trapezium 3, 4, and 5. Right? There's trapezium 1 here, 2 here, 3, 4, and 5. Are you okay with that? So your x values are, so we'll do another table. X values are 0, 0.4, 0.8, 1.2, 1.6, and 2. And then the trick now is to get the y value. Right? Of course, there's your first value, there's your second value, there's your y2, y3, y4, y5, right? So you will know what going in the formula. Anybody lost us yet? Diane? Okay? So you follow how I got these values? Must be equal, eh? Yes, you good? Right. How we get y again? Any ideas? Substitute the x value in here. All right? So substitute the x value in here. So that's 1 over 1 plus 0 squared. So I got it to be 1. 1 over 1 plus 0.4 squared. You always do your thing and tell me how much is that? How much is that? I get the right, if you need back in the car seat, there's space in front, huh? All right. You need back in the car seat. Okay. If they give you an exact value, leave that, right? So you don't have to wrong about too much. Oh, by the way, put this in the calculator now. Tell me what it is. Put this whole thing in the calculator. Tell me what it is. Wait now, let me make film pure photo. I will see it again. Okay. We will make page of all. Huh? If it could give my exact fraction. So we do wrong. 25 on 29. So this one here is 25 on 29. And then do all the others, right? All right, let's go. Right. Try not to round off, right? What you all got here for 0.8 fraction? 5 on 25 on 41, 1.2. 25 on 61, 1.6. 25, right? 89 and 2. 1 third. Right? Anybody put this in the calculator? The first thing. 1.107. Okay. Let's see how close we got to that. So we're using the trapezium rule. That's the integral between b and a of 1 over 1 plus x squared. And then you plug in this. H is 0.4. Y, which one is y0? Y0 is the first value, right? And yn is the last value. All right? So that will be 1 plus 1/5. That's the first and last value. Plus 2 by all the other values. So that's 2 by 25 on 29. Plus 25 on 41. Plus 25 on 61. Plus 25 on 89. Tell me what you got. Anybody else? 1.11. Right, not bad. We almost get the same. We almost get the exact thing there.
It's 1.15.
That's this.
Yeah.
1.105. Right, so that's your trapezium, and that's it. That's all you have to know.
This one is underestimated.
This one will be under, yes. Right, be underestimate.
Here we go. 5 minutes, pretty good. Right, but
Then later on, I'll give you a break.
10 minutes.
5, you know, what's the 5 when you want to 10? Huh?
Finish with the top first class.
Yeah, if I give you a reduction formula and you get it right, yeah. Again, 10 minutes.
And that because he watched the video.
Right? One past paper and we done. We're done. How I get? You get a calculator, went to the calculator and do it. Put the whole thing in the calculator. Any questions here earlier?
Nah.
Okay, that's not happening. Right, so we are doing part C. C part 1 alone, forget the actual.
Square. Yeah.
No, just unit. That's
One unit here. Square.
one unit
Square.
one.
Square. Cube. One cube. Cube. Yeah, it's cube.
Or what did you?
Not even. No unit. Yeah, but cubes. I know, but square.
You could think about it. Right, you are doing C part 1.
So I wasn't struggling.
Oh yeah, try that in now. We are doing C part 1 for the 9th time. C part 1. I don't know what yet. C part 1. Really doing what? Right and say what? Okay, C part 1. Oh yeah, Paul, yeah. Tolina. Go ahead, distract you. I didn't say. Yeah, it's not there, not there. I don't have the year.
I think so. This would be. Yeah, there is good. Wait, no, I'm more than that. Shaking from having. You know, so many people, we have two more games. Next week, second Friday. What are about to something about no, but we can come from before. We can just look down at them. That's what we got. Yeah, well, that's yeah, that's
You all done? Take your time, right? It's just plugging in the values. What you all got? On your, what are the X values you all got? Dash. I mean, no, yeah, sorry. Sorry, yeah. Sorry, yeah, sorry. They want three equal intervals, so what's the value we're going to use? X to the 5.
2, 3, 1.
Right, so so n is how much?
And it's 1.
What?
Oh no, and it's 3.
And it's 3.
It was 1.
And it's 3, each is 1. But okay with that? Anybody confused? Because
Wait,
I'm not doing that anymore.
yes.
Huh? Anybody else confused? Any question?
No, he said I have 3 and those 3 is 3, but I signed in. Right? Right? I'm single.
Question says, I'm sure you get one.
No, this is the teacher.
BS5, 5 is fine each. Each is 1.
What?
5 is fine each.
Where's my name? Yes.
Let's finish quickly calculate and compare the values. See if it's over or under.
Good, so a lot of that's in the middle.
And wash boy man.
Yeah.
Right, I'm gonna correct this one now, right? Online, you can message the answer you got. Right. When x plus 2, what you got for y? Right, so as I said, once you could, please use the fraction, right? How much you got? 11 on
5,
number, when x is 3,
9 on 10,
when x is 4,
9 on 7,
when x is 5.
19 on 52.
Nice. So now we need to get the integral between 5 and 2 of f of x with respect to x, right? So that'll be a half of each. Each is 1 by first value, last value, right? Plus 2 by the other two values here. 9 on 10 plus 9 on 17. How much is that? That's a fraction. Are that a fraction or decimal?
We got a fraction, a big fraction, but we split in a decimal form.
Oh, tell me what is the decimal form?
2.712.
2.712.
12, not 9. But it's square.
Right?
What's square?
And when you integrate this, anybody try the long way? I mean, in the calculator, 2.5, right? So we're with a over exclusion.
So this graph goes so then. The last graph goes so.
Total. All right, nice. 5 minutes, and then we start back reduction formula. 5 minutes, then reduction formula, right? So what we're gonna do, we're gonna review some examples and then we practice some. Online, are you okay with this? You get similar values? Five minutes earlier. That's the end of module 1. That's next week. Module 3, so we start next week. Okay, 3. Five minutes start, started now, right? I don't, let me know that. Like, I'm gonna. Then I'll do it. But only doing full total. Dinosaurs. Oh, itu lo tuh ambil dan sampai kalau dan ini, kalau aku masih sama oke. Oh, you know the
But now it's still available. I mean, that's what they name at the schools. How you lives, that's the for field units. Or unit one, physics, I think that's some, all the classes that you have. What those that you record, or record. Definitely one. Right, so, but and right now, the website. On the LMS, yeah, but that will be the year before. Oh, that one. Ones that are available, ones that are available from this year. Yeah. That will be YouTube on YouTube for now. Till I find out what happened is they're all public for now. Until I find a way to give you access to that and post it up. Trying to create a group where you all can access all and everybody else can access it. Yeah, so I can't do that for yet. So I just leave it open for now. This way you pay the access. Also, it's on YouTube, right? Alright. And it's school and so and that is all that secretly so far. I think so far. And what you want to go ahead, that's what you want right now. And I want to say this.
I guess.
All right, let's go now. So we started this one. I think I have a sleep book already. We started this one and then we continue, right?
Yeah, you're so.
No, I'm going to go through this one. Right. But I don't think you have to write it because you have to correct it. I think so. All right. So the attempt here is to go over reduction formula, and we can do a couple of questions to make sure we understand what to do, right? I think I did this one already. Right? I think I did this one already. So you don't have to write it, just watch it. Watch the process, right? All right. So all right, so good. So you all remember how to integrate things like this? To integrate things like this, we use product, we use integration with parts, right? But the problem is if I put I3 here, how many times do I have to use integration with like parts? Probably about 3 times. So now there's a way that's a little bit shorter by creating a formula that allows us to just plug in n values and find the integral. Okay, that's called a reduction formula. So stage 1 of reduction formula is to be able to take this integral and turn it into this. All right? So we start in here. I to the n is the integral of 1, 0 of x to the n dot e to the x. Now, how do I know which one is u and which one is dv? This is for your integration right by parts, right? Remember integration by parts? One you differentiate, one you integrate. We need to figure out which one going where. So sometimes I'll tell you, okay, here what to do. Write down I to the n minus 1. That will be the integral between 1 and 0 of change n to what? N minus 1. So basically, we are trying to get this here. What does that tell you? You okay with that, Esther? So you follow how I got n minus 1, right? I to the n is this, so I to the n minus 1 is this. Okay? So I am trying to achieve this. How can I get minus 1 at the power? It means that I'm going to have to differentiate to get this. Differentiation is minus, integral is added. So what that means is that I am going to differentiate this. I am going to integrate this. All right? So I'm going to differentiate this. I'll get n x to the n minus 1. I am going to integrate this. What's the integral of e to the x? E to the x, right? What's the integral of e to the 3x? 1 over the differential of this e to the 3x. That's okay? So 1 over the differential of this by the original thing, right? Nice. So now I know that I to the n, what's the formula for integration by parts again? Formula is u by v minus the integral of v by du. Okay? U by v, so that's x to the n e to the x minus integral of v e to the x by du. Right, remember, and I can pull constants outside. So I pull in the n outside and I put in x to the n minus 1 here. Anybody get lost? Yeah? You sure, Amber? Right? So I put in, I plugged in u, I plugged in v, I plugged in v, and I plugged in du. Right? I just took the n and pulled the n on the outside. Everybody okay with that? But remember, we're dealing with limits, right? So here has to have a 1, 0. Here has to have 1, 0. Clear? Okay with that? So this is I to the n. When I plug in 1 here, I will get 1 to the n e to the 1 minus, when I plug in 0 here, I'll get 0. That's okay? Because x is 0, right? Minus n by, what is this here? Seen it there? Seen it? So the integral of e to the x at x to the n minus 1 is the same as that. It's just at the e to the x in front here. So you will end up with I to the n minus 1. Yeah? Finish? Where you lost? All right, well, let mark this up here. All right. Are you okay with that? Right? And we know 1 to any power is what? 1 to any power is 1. So this becomes e minus n I to the n minus. All right? And that is a proof. We're done. Of course, they all do be that easy because here now you have to figure out how to simplify to get what you want. Okay? That's the part where you have to use a critical thinking ability and try little things. All right? It's not all simple like this. Sometimes they'll break, they'll change like. But it's the same process, right? Now, watch this here. What they asked me for? They asked me to find I3, right? So how do I get I3 now? To get I3, I'm going to use the formula. I3 is equal to E minus, remember, N is 3, 3I2. Are you okay there? So I put 3 here, I put 3 here, I put 3 here. and I get that. Are you okay with that? But I'm not done because I need to get I2. I2 will be E minus 2 I1. I'm not done. I need to get I1. E minus 1 I0. So I can find I0, right? I0 will be E minus 0. I0 will be E minus 0 by anything is 0. So I0 is E. What do I do now? Put I0 here. So put I0 here, I'll get E minus E, which is 0. Then put I1 here. So I'll get E minus 2 by 0, which is E, and then put I2 here. So that'll be E minus 3E, which is minus 2E. That's your final answer. Right? Watch it again. So how do I get I3? Put I3 in that formula. Put 3 in that formula. I3 is E3I2. I need to get I2. I2 is E minus 2I1. I need to get I1 now, right? So put 1 in there. E minus 1I0. I need to get I0. Put 0 in there. You'll get E minus 0. Once you have I0, put it back here. Work it out. I got 0. Once you have I1, put it back here. Right? E minus 0 is E. And once I have I2, put it back here. E minus 3 will give you minus. That's the final answer. Right? That's the principle behind reduction formula. Are you okay with that? We didn't, I think we do this already. If not, write it down. No? Oh, okay. Sorry? I do them yet. But I want to make sure we do them because there are any errors. Yeah, so let's do them out. One there, one there. I0 is E. So I put E here. E minus 1E. And I end up with 0. And then I put 0. And I end up with 0. The fire couple, yeah. What am I making for it? No, we're going to go together because I'm going to sit down next year for the next one. Come right in. Come right in. Yo, let me take my picture and then first now. Alright. Right, so we have it. Alright. I'll just send the explanation now. Yeah. And let's take it on the start, okay? Try that, please. Try this one here. Number 2. You have to find I4, right? But I try to do some more calls, so I will sit down. What do you want to give me? But you recognize that one and that he didn't take off. Probably they probably get
Oh, I know what they are. Oh yeah. Anyway, stop. Nice stuff. 3. Alright, that's better. Alright, it's better. Alright, that's better. I'm sorry. Alright, that's better. Exactly. Is it reading?
Remember, you have limits, right? Don't forget you have limits, so plug in your value.
Yeah, I did. Oh. Wait, but still, go ahead, and go ahead, right? Oh, I didn't mind. But it's not. Wait, I didn't hire. What? Oh, I got oh, that was good. I had good too. I suppose yeah. And it was one. Yeah.
Remember the answer I4, right?
Yes, sir. But as when you go to use the three
Yeah, one by one, put together my one at a time. Right, as in the mistake when you're plugging in the one and the zero, right? I'm gonna start with just now. Should be in terms of eight. So it means it's on the way. Oh, you could go like. Yeah. I don't know, I'm gonna try it now, right? You all got it? Daniela, all again? All again proof? Yeah? So far, you can't see, so you don't know. Hmm? Which working it out? Oh, you get this one? Yeah, power if you want, that's what you might. Put one to the end. Right, so I just taking my time and I'm going to differentiate. Bring down the n, differential of 1 minus x is minus n. Write back the bracket, determine the bracket and minus 1 for the power. The integral of e to the x is e to the x. Right? So now I know that e to the n between 1 and 0 is this by this. E to the x by 1 minus x to the n. This is u by v, and I plug in the limits. Minus the integral of du by v. But look at it one time, right? I don't want to bring in I don't want to put the minus n in. Right? I just factor in that one time. Actually, I write it. Minus n by 1 minus x. So I put in du by v. Dot e to the x. Dot dx. So what is that number? So I plug in uv minus du by v. Right? Minus and a minus, that'll become plus, right? So this is 1, 0 plus n by the integral of 1 minus x to the n minus 1 dot e to the x dx. Right? This here is what? If I to the n is this, what is I to the n minus 1? I to the n minus 1 will be the integral between 1 and 0 of e to the x by, just change this to n minus 1. So this is the same thing here. Right? So now I have plus n to the n minus 1. This whole thing becomes that. Right? This here is I to the n minus 1. Seen it? So therefore, this here becomes that. Now I had to focus on here. Right? How do I work out this? Well, I'm going to plug in 1. So I'll get e to the 1 by 1 minus 1 to the n minus, plug in 0 now, e to the 0 by 1 minus 0 to the n. This becomes 0. That's okay? This becomes 0. So we will get 0 minus, this becomes what? E to the power 0 is 1, 1 to the n by 1 to the n minus, sorry, plus I to the n. This 0 cancel off. 1 to any power is 1. So I'll be left with minus 1 plus n I to the n minus 1. 1 to any power is just 1. So now I have the answer there. What I have to do is just flip it around, right? So I have I to the n is n I to the n minus 1. Minus 1. The number? Yeah. We gotta remember how to do this, right? Plug it in and simplify. All right, now they want I4. They want I4, right? How do I get I4 now? To get I4, n is 4, so I'll get that. I can't stop there because this have I3 in it, so I have to get I3. I3 will be 3, I2 minus 1. So I have I2 there. So now I need to get I2. Now I need to get I1. Right? Now I need to get I0. Right? Put 0 here, that'll give it 0. So I got I0 to be minus 1. Right? When I put 0 here, this whole thing becomes 0, and I'm left with minus 1. What do I do now? Substitute I0 everywhere, right? So this becomes 1 by minus 1 minus 1. I got minus 2. Right? Now put in your minus 2 up here. 2 by minus 2 minus 1. That's minus 5. Put in your minus 5 up here. I got 3 minus 5 minus 1 minus 16. Come up here. 4 by minus 16 minus 1. I got minus 65. Huh? That's it. That's how we handle this. All right? Samira? I can what I had one now. You have no choice, right? You gotta get a harder one. That is plus the past. Are you writing? Oh, writing. Go ahead. I want to give you one more, right?
Last year.
Like a triangle this, you look very studious.
Ready? Let's try this one here. Huh? No. Right, Darion. That's I to the end. That's what you had to prove, right? What do you think is U? What do you think is V? What do you think is U? And what do you think is DV? What do you think is U and what do you think is DV?
I think one is you.
Yeah, I'm here. 1 plus x squared is what? U. And n is what? I mean, DV is what? 1. DV is 1. So you're going to differentiate 1 plus x squared?
Yeah.
1 to the power n.
Yeah, with the end.
With the n. So you are including up 1 here, right?
Yeah.
Yeah. So you're going to integrate the 1 and differentiate the. All right, that could probably work. Try it and see. Right, what? You have n minus 1. How else you'll get that? How else would you get n minus 1? You're going to have to differentiate, right? Okay, so take your time, huh? This one a little more complicated because you have these little fractions to get. The second part is the part to find I4, but ignore that. We don't have time to find I4. I'll give you a few more to try as well, right? Four more. And you can do it, I'll post answer. Right? Next week we start module 3. We start something called differential equations, right?
So what the boyfriend?
Module 1.
Or still wrong.
Or direct right? So we're doing module 3, we're doing something called differential equations, which is a continuation and integration. We're doing first order and second order. Well, first order or next. Actually, we're back to have the paper. But last we can do this 7 o'clock tomorrow. I got it. Take it down. And so far we reach. We have 10 minutes again. Some of you all differentiate them farther. Some of us see if you all have the same thing. dV is what? What is dV here? Bring down the n.
You mean du?
Sorry, du. Sorry.
And
Bring down the n, differentiate the bracket, write back the bracket, and then minus 1. So you end up with 2nx by 1 plus x squared to the, right? And what's the integral of 1? Okay. Go ahead. Please remember you have limits substituted. Let's see what you end up with. Of that works out. I can see it. I don't see it beside, but maybe when it will be without your. No, just to be the right. Yes. Yes, sir.
say it after it twice.
Looking like that. Looking like that, do it twice. Or if not twice, maybe try substitution and see what happens. We end up x squared.
Yeah, what on the
You end up with 2nx squared.
yeah, and up with 2x squared by 1 plus x squared. Take off and minus 1. X squared is only like x. Like that. We bring only n. And brought in.
Yeah, Kasha? No, nothing anywhere. And let me next part and 4. So there's something that you had to do. So watch this here. Anybody recognize this? Something that we did earlier. Well, I mean like something with. How do we get something like this? Already remember partial fractions? Remember partial fractions? No? So watch this here. So sometimes, you see this here telling me that, you know what? If I go and integrate again, and I will get n minus 2, and I will get something like that. I don't want that, right? I want to stay n minus 1. So it's telling me maybe it's not integration by parts. So let me see, right? Let's see. So I have I to the n is equal to u by v, which is x 1 plus x squared to the n between 1 and 0. That's not. Hello. Right, so watch this here. So when I reach here, right? Oh, sorry, I ain't done yet. Minus the integral of this by this. So I'll get 2nx by 1 plus x squared to the n minus 1 by x. Right? I want to show you two little things here. Everybody watch here now. I'm doing it right here. This is x by x, right? So can I write x squared?
No.
Are you okay with that? Right, but watch this piece here. This is 1 plus x squared to the n minus 1, right? Yep. So I just want to try something here. Instead of writing my n to the minus 1, can I write this? Are these two the same thing? The reason I'm doing this is I'm trying to find a way to get a little fraction somewhere. Right? And watch what will happen. Yeah. Huh? Oh, all right. All right. Right? No, but after you do one like this and you see it again, you'll be able to figure it out. Right? So if I put it two n outside, it looks like this, right? If I put the 2n outside, it looks something like this, right? Yeah. Can I simplify this a little bit? What will that be? What type of denominator is that? I'm a little partial fractions, right? Let me leave it 2 here. Let me leave, does it matter? I see n 2n there. Let me leave the 2 here. I'll just factor it out anyway later on. Right. How do we simplify this earlier? How do we simplify something like this? Highest power of x is 2 here, highest power of x is 2 here. So what do you normally do? What do you do? Long divide, very good. So let's long divide 1 plus x squared into x squared. I'm going to do 1 after, right? X squared into x squared is 1. 1 by x squared is x squared. 1 by 1 is 1. Then we minus, right? So you'll get 0 minus 1. So your final answer is what? Your final answer is 1 minus 1 over 1 plus x squared. Remember that? Yep. So to simplify this partial fractions here, I long divide x squared into x squared is 1. 1 by x squared is x squared. 1 by 1 is 1. Then you minus. That's okay? Now, let me jump back in there now and see what happened. So, I to the n is equal to, I to the n is equal to, can I just plug in the 1 and 0 here? Right, make sure you're following. You might be able to do the rest after this, might. Right? I just plug in the 1 and the 0. If I plug in 1, if I plug in 0, I get 0, right? If I plug in 1, I'll get 1 by 1 plus 1 to the n, which is minus 0, which is 2 to the n. So this whole thing here becomes 2 to the n. And you should see that somewhere. You see that there? So now I have 2 to the n minus 2 to the 2 by n by the integral between 1 and 0 of, let's plug in this now, 1 minus 1 plus x squared by 1 plus x squared to the n. So all I did is I replaced this with this. I'll do it myself. You're almost done. So you'll end up with I to the n is 2 to the n minus 2 to the n. I just multiplying this slightly by the integral between 1 and 0 of 1 plus x squared to the n, this by 1, and then this by this. Dot dx. Right? So I to the n is equal to 2 to the n minus 2 to the n. When I simplify this, I will get the integral between 1 and 0 of 1 plus x squared to the n. You recognize this? What this is? What this is here? In, right? Minus, what will happen here? Well, and that will get back what I started with. And this is to the power 1. So I'll get 1 plus x squared to the n minus 1. So it's time to work out now. So you end up with I to the n is 2 to the n minus 2n by, this is what? This is in. This is in minus. And just rearrange it and you'll get out. Right? Multiply it out, bring the ions together, and then divide it out. Right? So I know it's looking real hard, but you'll follow this step here. It's something I never did before. You'll follow this step. This was the tricky step here. Right? Oh, we knew we had to do that because if I integrate twice, I'll end up with I to the n minus 2. Okay? So this is basically a reduction formula. There are questions where you're going to have to, how to put it, think out the box. Right? You're going to have to try something. All right? Right? Finish up the rest of them, right? You still have 3 more lines. Actually, I might even finish. So this is I to the n is 2 to the n minus 2n I to the n plus 2n I to the n minus 1. Carry it across. Carry it across. And you'll get I to the n plus 2 to the n I to the n. Huh? Where I move up? Yeah, I move all the I to the ends on the left. And then I factor it out. Okay, and then I split up this using this to get it in therefore. When you split this up, you get this. Yeah, tell me. Where what going?
Oh, yes,
Yeah, I do this similar to what happened up here. Okay. So that was a hard one. So we went from medium to hard today, right? But you got okay with it medium.
yeah.
So my advice there is to what? Create for medium, right?
So,
Right, but still, I want to practice a few more of these. There would be like 3 topics in. There were like 3 topics in unit 2 that come like this, kind of open box. This is one of them. Yeah, this summations, right? This something in module 2, and well, who do not even apply may not like problem. I thought I think about a month, but still take a while. I need to get it. Some people get, some people apply because it's kind of it'll be like apply. All right, on